What are both ordered pairs of positive integers x, y, which satisfy 3x plus 4y is 25? Well, I guess you just have to look for integer solutions. So make a list x, y, and then since they're positive, just start with the first positive number. If when x is 1, this will be 5.5. When x is 2, this will be 4.75. When x is 3, this will be 4. So we got 1, and they're saying there's 2 since they're asking for both. When x is 4, we have 3.25. When x is 5, we have 2.5. When x is 6, we have 1.75. When x is 7, we have 1. So there we go. So the two ordered pairs of x, y that satisfy that equation are 3, 4, and 7, 1. For what value of k is the ratio of root 2002 to root 2002k the same as the ratio of root 5 to root 2? 2002 root over 2002k root is the ratio of root 5 over root 2. Okay, so I think we just square both sides, and when you do that, that just gets rid of all the radical signs. So then you just get 5 over 2. And then this, of course, just reduces to 1 over k, which is 5 over 2. And then you just flip it to get 2 over 5. And 2 over 5 is the answer. When I first purchased my first catapult for 2000, it needed repairs. The first repair cost $200. Each subsequent repair cost 10% more than the repair just before. After how many repairs could I first correctly cry, I already spent more for catapult repairs than I spent for the catapult? Okay, well, let's make a tally here. Let's say repair number and then the total amount. So the amount and then the total amount. So I'll explain. So we start off with the first repair, and they even tell you it's $200. So far you spent $200 on repairs. Okay? And then the second repair is 10% more than the previous one, so that's $220 this time. So now the cumulative total would be $220 plus $200, which is $420. Okay? And then the third repair is 10% more than the $220, which is $242. And then the cumulative total would be the total of those three, which is $662, I believe. Yeah. And then just keep going like this. And eventually, once the total exceeds the 2000s, then that is when you have spent more on repairs than the cost of the catapult. So let's just keep going here. Fourth repair is, you can do this in your calculator, 266.2, and that would be 928.2. And then the fifth repair, 292.82, and then 1221.02. Sixth repair, 322.1, and that's going to be 1543.1 approximately. And then the seventh repair, 354.3, and this will be 1897.4. And then finally the eighth repair, that's the one that puts you over the 2000, 389.7, and that's 2287.1. So that's when you can cry, I already spent more for catapult repairs than I spent for the catapult. And that happens after the eighth repair. What is the only ordered pair of real numbers that satisfy 7 to the power of x minus 11y is 0 and 11 to the power of x minus 7y is 0? From the first equation, we get 7 to the power of x is 11y. From the second, we get 11 to the power of x is equal to 7y. Correct? So from this one, we get 7 to the power of x over 11 is y. And then from this one, we get 11 to the power of x over 7 is y. Is that right? Yeah. So set them equal to each other, I guess. So 7 to the power of x over 11 is equal to 11 to the power of x over 7. Cross multiply and you get 7 times 7 to the power of x is equal to 11 to the power of x times 11. So those are all to powers of 1. Using exponent laws, that would be x plus 1, and that would be x plus 1 for both exponents for 7 and 11. Okay, well the bases are not the same, so the only way that could be possible is if the exponents were 0, meaning this is 0 and that's 0. And therefore both would end up being 1. 7 to the power of 0 is 1, 11 to the power of 0 is 1. So if both of those are 0, that means x plus 1 is 0. That means x is negative 1. Yeah. Okay, if x is negative 1, I guess we just plug it into either one of them to figure out the value of y. So 7 to the negative 1 is 11y. So that means 1 over 7 is 11y. So y is 1 over 77. Okay, so xy is negative 1 over 77. The lengths of the legs of a certain right triangle are 18 and 63. What is the area of the circle which is tangent to both legs of the triangle and has its center on the hypotenuse? So let's draw this a little bit larger. And let's see what we can do here. So, okay, so I've got to draw this in a way that it's tangent. So something like this, right? Okay. Not the best of diagrams, but that's okay. So now let's figure this out. So we have the lengths are 18 and 63. So that's 18 and that's 63. And that's a right triangle. Okay, what is the area of the circle, which is tangent? Okay, so we got to figure out the area of this circle. And this, let's just say that's the center, which is tangent to both of the legs. And it has its center either on that. Okay, that's exactly what I was hoping for. And then they even show that in the diagram here. You can see that. Okay, so then if I draw a line from... let me think about this. I think the way I drew this, the diagram is not as good. Maybe I can just do it over here. Their diagram is much better than mine. I mean, I didn't draw it very much to scale, but you guys understand. If you draw those red lines, that will basically represent the radius of the circle. Yeah. And then this, of course, since it's a square, that's r and that's r. So therefore, since the whole side was 63, this is going to be 63 minus r. And this little guy up there would be 18 minus r. 18 minus r. And I think that would either probably help you. You can either use Pythagoras or you could probably use similar triangles. I think similar triangles might be a little bit easier. So similar triangles, for example, this triangle, this little guy up here, and this guy, those are similar in terms of their angles. So that means that 18 minus r over r would be the same as r over 63 minus r. And then I guess we just cross multiply. So r squared would be 18 minus r times 63 minus r. And therefore r squared would be 18 times 63 minus 18r minus 63r plus r squared. And then the r squareds looks like they cancel, so this is just going to be 18 times 63 is equal to, what's that, 81r? And then we can just divide through. So when we do, we get 14. So they want the area of the circle. Well, the area of a circle is pi r squared, and r is 14, so it would be pi times 14 squared. So that would be 196 pi. What is the maximum value of x for which there exists real numbers x and y which satisfy these inequalities? So the first one, x plus y, is between minus 10 and 4. And the next one, x squared plus y squared minus 36 times x plus y is less than or equal to 2xy. Okay. So just to make matters simple, let's let a equal x plus y and let b equal x minus y. Because this x squared plus y squared, obviously we're going to have to use a multiplication. So what that does is it makes these inequalities as follows. The first one, let's see here. If we add them, it would be a plus b, the y's would disappear, and then x would just be a plus b over 2, like that. So if we take that second one, x squared plus y squared minus 36 x plus y is less than or equal to 2xy, like that. If I bring this guy over like this, then that will help me, because that looks very similar to something I know. And then bring that guy over here. So that I can, and factor, that's x minus y squared. And that's the whole point. And there's a little bit of fancy algebra. Not extremely fancy, but a little bit. And now I can substitute these guys, and it'll make it look a little bit better. So this is basically b squared is less than or equal to 36a. Yeah. And then we know that from this guy, minus 10 is less than or equal to x plus y. But x plus y I've called a. Okay, I got it. So we want the maximum value. What is the maximum value for x? All right, maximum value for x. Well, since we're looking at maximum values, let's look at the maximum of a. The maximum for a is 4. Correct? So if that's the case, let's plug that into there and see what happens. B squared would therefore be 36 times 4, and therefore b would be less than 6 times 2, which is 12. So therefore the max for b looks to be like 12. And therefore x, the maximum value for x, since x is equal to a plus b over 2, that would be 4 plus 12 over 2, and that is equal to 8.